Kia ora. It's time to go through this example on circular motion. This question is about Kate and William, and they are on a merry-go-round. Now, before I even start the question, I want to draw a diagram of what we're actually working out, because actually decoding the question is really important, and sometimes drawing a diagram is a really good way to do that. So we've got a merry-go-round of radius 7 meters. So I'm just going to draw a circle and show there that the radius is 7 meters. And it makes one complete revolution every 30 seconds. So to get from start to the finish, one revolution is 30 seconds. Kate stands on the outside while William stands 3 meters in from the edge. So let's draw. Here is Kate. She is 7 meters away from the center. Away from the center. But here's the trick. William stands 3 meters in from the edge. So that means that he is actually 4 meters away from the center. That catches people out. Okay, 4 meters away from the center, and that's because he's 3 meters in from the edge. So just so that you know. So let's have a look at part A. What is the period? So the word period means the time taken for one revolution, and it's given a capital T. And so we're told in the question that one revolution takes 30 seconds. So that's your answer for A. Question B, it then asks for the frequency. And the frequency and the period are related because period is 1 over the frequency, or frequency is 1 over the period. So frequency is how many turns in 1 second, period, how long for one complete revolution. So if we want the frequency, we have to do 1 over the period. So in this case, that's 1 over 30, okay, which gives us 0.03, and the unit for frequency is hertz, and that has the symbol capital H, small z. So it's 0.03 hertz. Question C, what is Kate's speed? So speed is distance over time, okay? So, and she's going at a constant speed because the merry-go-round goes round at a constant speed. So there's no acceleration. So how do we work out distance? So we're going to have to delve back probably to our Year 9 maths, and we're looking for how to work out the distance around the circle, okay, which is the circumference, and that's 2 pi r, and the time it takes to move through that one revolution is the period, so that's why we change that to a capital T. So circumference is 2 times pi times 7, because she's standing 7 meters away from the center, and the period is 30 seconds, and that doesn't need changing because it's already in standard international units. If you work that out on your calculator, it comes out as 1.466, or 1.5 seconds to 2 significant figures. Okay, so the tricky bit there is remembering that the distance around the circle is the circumference, which is 2 pi r. Okay, let's have a look at part D. Calculate the difference in speed between William and Kate. This is going to be interesting because I wonder whether one of them is going faster than the other one. Let's have a wee look. So William, oh, a pen. William is standing 3 meters away, 3 meters from the edge, or 4 meters from the center. So his velocity is going to be, again, 2 pi r over t. And that's going to be 2 times pi times 4, because he's 4 meters away from the center. And he's still going to take 30 seconds to do 1 revolution. That comes out at 0.84 meters per second. So the difference is 1.466 minus 0.84, which is 0.626, or 0.63 meters per second. So while it takes exactly the same amount of time for them to move through 1 revolution, okay, William is going slower than Kate. Okay, part E, what is the size of Kate's acceleration? That's centripetal acceleration, which is v squared over r. So we've already worked out her velocity, which is 1.466 squared over 7, which comes out as 0.307 or 0.31 meters per second every second. And what is the direction of Kate's acceleration? Centripetal acceleration is always towards the center of the merry-go-round. So remembering, I'll just draw a little picture here to remind you that if Kate is here, the net force, the centripetal force, is towards the center. Centripetal acceleration is towards the center. And if the merry-go-round is turning, let's say, in a clockwise direction, then the velocity will be at a tangent to the circle in that clockwise direction. That's just a little bit of a reminder there. If you don't follow anything in this video, please ensure that you come to a tutorial or ask your teacher for help. Thanks.